Good morning, Pirates. Today we're going to look at what a precipitate is. In order for a precipitate form, we have to talk about a precipitation reaction. A precipitation reaction is a type of chemical reaction. It is also a double replacement reaction, which I'll explain when we look at them. It's two compounds added together, where two soluble solutions, that means they dissolve in water, are combined and form an insoluble or a new solid. And that new solid is called a precipitate. Our first example is going to be sodium carbonate added to cobalt to nitrate. When we take sodium carbonate and cobalt to nitrate, you will see beforehand they're both aqueous solutions. And if we put them together, we now see a precipitate form, these chalky, thick, pink particles. We now need to figure out what that pink precipitate substance was. In order to do that, we need to look at a double replacement reaction. Sodium carbonate and cobalt 2 carbonate are two compounds. So this is a double replacement reaction where they are going to switch partners. In order to switch partners, the outer elements are going to form a substance or compound together. These are the outer elements or substances. And the inner substances. So the carbonate ion and cobalt ion are the inner substances that are now going to form. So if we look at this, sodium and nitrate are going to form a substance, and carbonate and cobalt, the inner ones, will form. However, the cation, in this case the cobalt, goes first. And we need to look at the charges to figure out what their formulas would be. So sodium, if we look in the periodic table, has a +1 charge. And nitrate, if you look on your polyatomic ion list, has a -1 charge. So we know those are going to balance out to 0 or crisscross to 1 and 1. So our formula is going to be Na1, which we don't write, NO3. And then if we look at the cobalt and the carbonate are a little bit tricky. The cobalt in particular, we have to look at the reactant side to see what charge cobalt was, since it's a transition metal. Since nitrate has a -1 charge, and there are two nitrate groups here, -1 times 2 means the nitrate has a total -2 charge. Therefore, cobalt must have a total +2 charge in order for that compound to be neutral or add to 0. So cobalt has a +2 charge. Carbonate, if you look on the polyatomic list, has a -2 charge. So now +2 and -2 add up to 0. So we only need one cobalt atom and one carbonate ion. Now, the whole purpose of this was to figure out what was that pink precipitate we saw. The rules are very simple. If you look at the charges down below, anytime you have a +1 or a -1 inside a compound, you have a soluble solution or something that dissolves in water. So if we're trying to identify what the pink solid precipitate particles were, it cannot be NaNO3 because they were positive 1 and negative 1. However, in the other compound, Cobalt-2 carbonate, we have a positive 2 and a negative 2. So this is the identity of our precipitate. Okay, and the way that we show that is when you write your reaction, you put an S or solid after it. So the precipitate that was formed, the pink precipitate, was Cobalt-2 carbonate. CO3. Now, the other part we need to talk about are these sodium ions. So if you look here at the beginning, we had sodium +1 and nitrate ions in these solutions to begin with, and we still have those ions sitting there at the end. Those are called spectator ions. A spectator ion are ions that do not take place in the reaction. So therefore, they are found in solution before and after the chemical reaction. Similar to spectators in a basketball game or football game. They're the ones cheering everyone on, however, they're not a part of the action or the tackle. Let's take a look at another reaction. If we were to add copper to chloride solution to sodium phosphate. If we take copper 2 chloride and sodium phosphate and put them together, you see a blue precipitate form. I got some cloudiness and particles. Now we need to figure out what those blue particles were or what precipitate was formed. So we know it either has copper in it or sodium in it because it needs a positive ion, and it either has chlorine or phosphate. So if we remember, our outers go together in a double replacement reaction. And our inner substances, and this time chlorine and sodium will go together. So let's look at the first one. We said copper and phosphate will form a substance. Now, to figure out what charge copper was, we have to look at chlorine here. Chlorine is always a -1 charge because it's in the 7th family or halogen family. -1 times 2 means there's a total -2 charge. Therefore, in order to make sure the compound is neutral, this copper has a +2 charge. We bring that over here. Now, if you look on your ion sheet, phosphate always has a -3. If we crisscross these charges, we get Cu3, PO4, parentheses 2. Now, if we look at both of those charges, it already looks like it's a good chance that's our precipitate because we have a +2 and a -3. And in order to form a precipitate, there is no 1 charge. Opposite rules from solubility. In order to form a precipitate, the charges, both charges, have to be greater than or equal to positive or -2. Now let's practice writing our other substance. We have chlorine and sodium. Sodium will come first because it's on the left side of the periodic table and it's our cation. Sodium always has a +1 charge if you look in column 1, the alkali metals. And chlorine always has a -1 charge. So if we crisscross that, we get NaCl. Sodium and chlorine must be our spectator ions because the The positive one and negative one charge tells us that they have a weaker attraction, that water can rip apart those ions and keep them apart. So in this reaction, the spectator ions are sodium, because they're ions at the beginning and at the end, and chlorine. And in this reaction, the PPT, which is short for precipitate, so the blue solid particles are copper 2 phosphate.